Picture, if you will, the moonlit surface of our closest celestial neighbor, the Moon. Beneath its dusty, cratered exterior lies a treasure trove that could potentially transform the way we produce energy on Earth. We're talking about helium-3, an isotope present in the lunar regolith. In this video, we'll explore the intriguing world of lunar helium-3, the promising designs of fusion reactors, and the ambitious plans of Artemis and Blue Origin to mine this resource. We'll also use a clever analogy to understand the mining process and examine the economic implications by comparing the costs per kilowatt-hour of energy. Imagine mining the surface of the Moon, much like filtering coffee. As a coffee filter sifts out the essential flavor from ground beans, advanced machinery designed by aerospace engineers could sift through lunar soil, or regolith, to extract valuable particles of helium-3. This isotope is rare on Earth, but abundant on the Moon because of constant bombardment from solar winds over billions of years. Helium-3 has garnered significant attention because it could be a promising fuel for clean and efficient nuclear fusion reactions. Nuclear fusion, combining atomic nuclei to release energy, is the holy grail of energy production. Unlike nuclear fission, which leaves radioactive waste, fusion using helium-3 is near emission-free and produces minimal waste. The excitement around helium-3 stems from its potential to revolutionize our energy sector. The challenge, however, lies in harnessing this power in a practical and economically viable way. To achieve this, scientists and engineers have been developing various fusion reactor designs. Among these, the tokamak and the stellarator stand out. A tokamak, which uses magnetic fields to contain hot plasma so fusion can occur, is the most researched. The stellarator, on the other hand, employs complex, twisted magnetic fields to achieve the same goal. Both designs aim to achieve a state known as ignition, where the fusion reaction becomes self-sustaining. The road to economically feasible fusion energy doesn't stop at designing reactors. There are enormous logistical and financial challenges to overcome. This is where the Artemis program by NASA and Blue Origin, founded by Jeff Bezos, enter the scene. Both have their sights set on lunar exploration and mining. Artemis aims to land humans on the Moon again, establishing a sustainable presence, and eventually creating an infrastructure for resource extraction. Blue Origin, with its Blue Moon lander, has plans for lunar cargo delivery, paving the way for commercial mining operations. The real test will be the economic viability of mining helium-3. Much like how a coffee filter separates a few grams of coffee from pounds of ground, mining machines need to efficiently separate helium-3 from tons of lunar dust. The process must be cost-effective to compete with Earth's energy sources. Currently, the cost of electricity from traditional nuclear or renewable sources is relatively low. Thus, the cost per kilowatt-hour of energy derived from lunar helium-3 would need to be competitive to justify the investment. The main hurdle here is the cost of lunar transport and mining. Developing technologies to navigate the Moon's harsh environment requires significant investment. But should these obstacles be overcome, the potential rewards are staggering. Helium-3-powered fusion reactors could supply abundant clean energy, a critical solution as we face global energy and climate crises. Ultimately, while the journey towards helium-3 fusion is lined with scientific and economic challenges, the prospects are undeniably exciting. The Moon could very well become our celestial coffee ground, producing the fuel that powers our small planet. Efforts by companies and space agencies moving towards moon-based resource extraction mark the beginning of a new era in space exploration and energy. As we continue our exploration of the cosmos, seeing our closest neighbor not just as a subject for poetry or myth, but as a valuable partner in energy, reminds us of what human ingenuity can achieve. The future might just hold the answers locked in moon dust, waiting to be harnessed by visionary endeavors and relentless perseverance. In the end, lunar helium-3 remains one of humanity's most tantalizing pursuits. A quest that could redefine our relationship with energy and propel us into the next quantum leap of scientific achievement.